Right now, in a remote testing facility in western China, engineers are pulling clean drinking water directly out of thin air. No river, no rain, no underground well, just air, and a machine that can make water scarcity, one of humanity's oldest problems, completely obsolete. 2.2 billion people on Earth right now don't have access to safe drinking water. Entire regions are running dry faster than anyone predicted. And China just built something that engineers are calling one of the most important inventions of the decade. This is a machine that could change everything. And here's exactly how it works. To understand why this matters, you have to understand how bad the water crisis has actually become. Groundwater levels in northern China have dropped by over 300 meters in some regions. Entire cities are sinking, literally sinking, because so much water has been pumped out from underneath them. This isn't just a China problem. From California to the Middle East to sub-Saharan Africa, aquifers that took thousands of years to fill are being drained in decades. Traditional solutions all have massive limitations. Desalination plants are incredibly expensive and only work near coastlines. Pipelines take decades to build and cost tens of billions of dollars. And in landlocked, drought-stricken regions, none of these options even apply. So Chinese engineers asked a different question entirely. What if you didn't need a river, an ocean, or an aquifer at all? What if the water was already there, just invisible, floating in the air around us? Because it is. Even in the driest deserts on Earth, there's still moisture in the atmosphere. The challenge was never finding water. It was pulling it out efficiently enough to matter at scale. The technology is called atmospheric water harvesting, and while the concept isn't new, what China has built is a version powerful enough to supply entire communities, not just a few bottles a day. Here's the process, step by step. First, massive fan arrays pull ambient air into the system continuously, day and night. Inside, that air passes over a specialized material, a next-generation composite that acts like a molecular sponge. It's engineered to grab water molecules directly from the air, even in humidity levels as low as 15%, far below what older systems could handle. Once the material is saturated, the system applies controlled heat, much of it from solar panels integrated directly into the structure, which releases the trapped water as vapor. That vapor is then cooled and condensed into liquid water, filtered, and mineralized to make it safe and pleasant to drink. The entire cycle repeats continuously, and unlike older atmospheric generators that needed huge amounts of electricity, this system runs almost entirely on solar power, meaning it can operate completely off-grid, in the middle of a desert, with no water source and no power lines anywhere nearby. Early test units are already producing over 1,000 liters of clean water per day, per unit. And because the design is modular, engineers can link hundreds of these units together to supply water for entire villages, or eventually, entire cities. But before anyone declares victory over water scarcity, it's worth being honest about the challenges. The technology still struggles in extremely dry, low-humidity environments, the exact places that need it most. Engineers are working to push efficiency even further. But physics puts a real limit on how much water you can extract from air that barely has any moisture in it to begin with. Cost is another major factor. While a single unit is far cheaper than a desalination plant, scaling this to serve millions of people will require massive manufacturing investment, and it's still unclear how affordable this will be for the poorest regions that need it most. There's also the question of maintenance. These systems have moving parts, filters, and specialized materials that degrade over time, especially in harsh desert conditions with sand, heat, and dust constantly working against the machinery. And finally, no invention exists in isolation. Even if this technology succeeds, it won't replace pipelines, wells, or desalination. It will most likely become one more tool in a much larger fight against water scarcity. Not a single silver bullet. Understanding these limits doesn't make the invention less impressive. It makes the progress that follows even more remarkable. If engineers can solve these remaining challenges, the implications are staggering. Imagine remote villages in sub-Saharan Africa, no longer dependent on wells that dry up every summer. Refugee camps with a stable water supply that doesn't rely on trucked-in deliveries. Disaster zones where clean water appears within days of a hurricane or earthquake. instead of weeks.
Hold it right there.
Imagine entire desert regions becoming livable again. Not through massive pipelines costing tens of billions of dollars, but through distributed networks of machines quietly pulling water from the same air that's always been there. China isn't the only country racing toward this technology, but its scale of investment and manufacturing capacity means whatever breakthroughs happen here could reach the rest of the world faster than almost anywhere else. The next decade of this technology will determine whether it becomes a footnote or one of the most important inventions of our generation. Because if this works at the scale engineers are hoping for, the question won't be where to find water anymore. It will simply be, why did it take us this long to look up instead of down?
"25 meters on the north side. Keep it moving to the center, watch the spacing.
Okay, easy now. A little to the left. All right, drop it. Get the wrenches ready.
Keep it coming left. Steady, steady. All right, set it down easy.
We are lifting, watch your spacing. I repeat, watch the spacing on the supports. Keep coming up.
Okay, pull.
Watch the edge there. Easy now.
Okay, bring it down slowly. Looks good from here.
We are clear at 20 meters.
Acknowledged. Continue ascent slowly.
Confirmed, serial matches the manifest. Okay, we are clear to lift on my mark. 3, 2, 1, mark.
Okay, easy now. Bring it left just a fraction. Hold it there, watch the clearance on the far side.
All right, team, secure the forward collar. Make sure those cables are taut. Copy that, tensioning now.
tension on line 3. Lower 2 meters. Watch the alignment pins. We are good to set.
Easy tension on the main hoist. Watch your clearance on the east side. All right, the section is seated. Initiating final lock and water draw. Control, we are clear for the lift. Tensioning now. Roger that, slowly lifting. Watch the tag lines.
All right, easy now. Bring her down 10 feet. Watch the saddles. Hold it steady. Easy now.
1 more inch to the left.
Coming down slowly. Watch the header.
Hold it steady. Align the next segment. We need more torque on bolt 12.
We need more pressure on the yellow jack.
Careful, watch the gauge. It's almost there.
Okay, hold it steady.
Okay, pull the cover clear now. Roger that. You are clear to lift on the right. Bring it down 20 millimeters.
Check the alignment on header 3.
Looks good. Keep lowering.
All right, easy now. Bring it down slow. Watch the alignment on the far side.
Yeah, we're good here. Set the brace. Lower it slowly. Watch the alignment. Looks good. Hold it there. A little more to the right. Hold it there. I'm securing the brace.
All right, slowly now. Watch the clearance on the port side. Copy that. Coming up easy.
Okay, pull the cover clear now. Roger that. You are clear to lift on the right. A little more to the right. Hold it there. I'm securing the brace. Bring it down slowly. Watch the alignment on the far side. Looks good here. Keep coming down.
Watch the manifold connection. Okay, hit the bolts. We are clear up here. Aligning the flange now.
Got it. Starting the torque sequence.
Lower it slowly, watch the manifold. Okay, clear on the left. Bring the cables over here. Wait for the wind. Okay, easy now, bring it down slow. Set it.
Pull it now.
We got it, it's lined up.
Descent rate looks good. Prepare for contact. Roger. Guiding the assembly in. Stand by for securing.
All right, easy now. Bring it down another foot and hold it. Watch the clearance on the right side.